All right, so we're going to do example 6.
What's the snippet?
In case you haven't noticed, we've started. Looks like a lot of you have not noticed, so I'll just bring it to your attention that we have started. So here we go. We're going to solve for x, but this time we got some decimals, okay? And there's a bunch of ways you could do this, but there's one particular way I think is the best way to do it. This is the way the book teaches, and I would agree with them that the way they teach you to do this is probably the best way to do it. So let's write it down. This is straight from the book, but write it down anyway. I'll read it off in a second. Oh, what's going on there? Okay, there we go. So it's 0.06x plus 0.07 parentheses 15,000 minus x close parentheses equals 990. All right, so we got to solve for x. This is where we're trying to get by itself. Now, where in the world do we begin? Well, what's the one thing about this problem that probably is probably the part that you don't like about this problem? X. The parentheses? Parentheses don't bother me. Say it. The decimals. It's the decimals. Okay, that's the thing that bothers me more than anything. All right, so what I want to do is make this. Now, you could work. Yeah, that's one thing I was going to do. I don't like you sitting next to each other. So, why don't you sit behind Caleb? X, why don't you sit behind Caleb? All right, so what we want to do is we want to get rid of the decimals. Think the problems before this, we got rid of fractions. Remember that? We found a common denominator. We multiplied everything by that common denominator. Well, this time, we're kind of going to do the same thing. But look at the fractions. I got a 0.06 and a 0.07. So what's it going to take this and make it a whole number instead of a decimal? What do you think, Ty?
It will be times 10 to the second.
Okay, times 10 to the second, or just move it how many places?
1 or 2.
2 places, right? If I move it 1 place, it's still a decimal, it's 0.6. But if I move it 2 places, then I've made that into a whole number. Agreed? What do we do when we move something to the right? Now, Ty actually said it. He said times 10 to the second. But what's a little easier way of thinking of it? Yeah, just times 100, okay? So we're going to basically times everything by 100, all right? Because moving the decimal to the right 2 places is multiplying by 100, all right? Times 10 to the second is 100, all right? But the thing is, I got to multiply everything by 10 to the second or by 100, okay? Now, this problem doesn't have it, because this one has 2 decimal places, this has 2 decimal places. What if you had one that had 3 decimal places? What if this was 0.007? What would you multiply by? 1,000. Right, 1,000. Even though this is only 2, you'd still multiply everything by 1,000. So the one that you have to move the most number of places, so the decimal that you have to move the most number of places in order to get it to be a whole number, you hear what I just said there? So the decimal that you have to move the most number of places to get a whole number out of it, that's what you're going to do to everything in the whole entire problem. All right. Now, both of these, you just have to move 2 places. So you're going to move everything 2 places or multiply everything by 100. So this is the way the book does it. I'll do it the way they do it. Okay. So I put a big old bracket around the whole entire thing. So I'm going to put 100 right here. Now, of course, the basic rules of algebra apply. Whatever you do to the left side, talk to me, you have to do the right side. Okay. So if I multiply the left side by 100, I got to come over here and multiply the right side by 100 as well. Okay? Everybody with me on that? So really, all we're doing, by 100, that's easy. It's easy to multiply by 100. We just move decimals 2 places to the right, to everything. All right? So let's do this. Let's move this thing right here. What's that going to become now if I multiply that by 100? It's going to be a 6x. Okay? Plus, this is kind of like, it's not kind of, it's exactly distributive property. So it's 100 times this, and you got a plus, so it's also 100 times this. Now remember, we talked about this a lot the other day. I don't know if Thursday, Friday, whenever it was. We talked about this. These 2 things are being multiplied together. So you only have to move this decimal, you don't have to move the stuff that's in here. Okay, remember we did that? We talked about, like, if I said, what's 3 times 5 times, I don't know, 4? You with me on this? Watch, if I started off with 5 times 4, do I have to multiply the 3 times the 5 and the 4? No, because it's not a plus in between. If it's just multiplication, I don't distribute a 3 through multiplication, only if it was a plus. So really, it doesn't matter if I go 3 times 5 is 15, times 4 is what, 60? Or I go 5 times 4 is 20, times 3 is 60. Or I could go 3 times 4, which is 12, times 5 is 60. That doesn't matter. The same thing applies here. So I'm only going to multiply that 100 by this 0.07. Everybody with me on that? It's kind of like this. It's just kind of like multiplying the 3 times the 5. I don't also multiply it by the 4. Same thing here. I don't also take that 100 and multiply it by this. But I kind of am in a way, because if I'm multiplying this by 100, okay, that's also being multiplied, all the stuff in here anyway, okay? All right, so enough said. What's this going to be then? A 7, and then we just keep all the stuff inside of here. All right, we don't need the bracket now because I've already taken the 100 times everything. Now, what do we do here? It's super easy to multiply by 100. Yep, 990, and then a couple zeros. Yes?
So you don't change the 15K?
Right. It's not K. It's 15,000 minus X. And I gave you the reasoning right here.
It means like 15K.
Oh, the 15K thousand. I got it. Okay. Saying it the cool way. I'm not cool enough to say that, so. All right. So, right, because of this. Because we don't also multiply the 3 times the 4 here, do we? Right? It's the same thing here. We've already multiplied that by 100. This is also being multiplied by this in the next step. So, kind of technically, this is being multiplied by 100, kind of. Okay? All right, so let's do this. Let's go, what's the next step do you think you might want to do here? Because we got all whole numbers here, so now it should be pretty basic. Ty? Yeah, take the 7, and I would distribute it through this. And you distribute because you got a negative in here. You got a minus sign. All right, so what do we got? We're not going to do anything with that 6x just yet. So 6x plus, what's that going to be? 7 times 15. That's 105. So 105, and then what? 1,000, 3 zeros. All right, 7 times 15 is 105. That's 105,000. Minus what? Minus x? Minus 7x. That's right, because you have to distribute the x through here. And then 99,000. Yeah, the numbers are getting a little big, but you got a calculator, right? Shouldn't be that big of a deal with the calculator. So what do you got here? Let's add like terms. I got a 6x minus a 7x. What is that? It's a negative 1x, okay? In the same step, you could do what? Subtract that 105,000 from both sides. It's basically just 105 minus 99. What's that? What's 105 minus 99? It's 6, isn't it? But it's negative because the 105 is negative, and it's 6 what? 1,000. See, we really haven't needed, maybe the 7 times 15, you might have used a calculator for that, because I don't have that memorized. I'm looking at my notes, okay? So I don't have 7 times 15 in my head, but anyway, there you go. Is my answer negative 6,000? No. So what do? You got a negative here. You could, well, I would do this. You don't flip it because it's not an exponent. It's not a negative exponent. It's just a negative 1 in front of the x. It's negative 1 times x. How do I get rid of something if it's being multiplied by negative 1? I divide by a negative 1, all right? Why did I do that? Because it makes it positive. Everybody see that? Now, technically, you could multiply by a negative 1 as well, but sometimes that's confusing because you're like, why did you multiply if it's already been multiplied? All right, so I always say divide by a negative 1. It's supposed to be a plus. That looks like a T or something. Anyway, you get an X right there. This is positive 6,000, and that's your answer. Whoops, forgot the 0. There's your answer right there. It's 6,000. So really, it's not that hard once you get rid of the decimals. All right, and to get rid of the decimal, that's the key step right here in yellow, is to multiply everything by 100. It's 100 because it's 2 decimal places. If it was 3 decimal places, you'd multiply by what? 1,000. If it was only 1 decimal place, you'd only multiply by 10. Okay? And then once you get to this should be fairly easy. Okay? Sometimes the big numbers mess us up a little bit. But if you have a calculator, it's fine. Use a calculator, figure out that stuff right there. We good? I was watching this math video. This lady, she was teaching. It just popped up on my YouTube suggestion thingy. I'm like, I'll see how because she was doing some of the stuff that we do in here and that we're going to do later on. I said, I'll see how because it's always interesting to hear how other people teach it. So I was watching. And man, for the simplest little thing, she'd bring the calculator out and she would use the calculator. And I'm thinking, oh my word, I would never tell them to use a calculator for that kind of stuff. But anyway, that's a matter of preference. But I mean, it used to be a teacher would say, because kids would say, why can't we just use a calculator? And the teacher would say this. They'd say, well, you don't always have a calculator on you, do you? But can a teacher say that anymore? No, because you always have a calculator on you because you always got your phone. All right. So, you can't even use that excuse anymore. So teachers are finding other reasons. All right, let's do this. Example 8. I'm not going to tell you the title of it or anything because something weird happens. Something really weird happens with example 8. And let's just go through the regular algebra. It says to solve. It looks pretty basic. It's like, well, I thought we were doing harder problems. I thought this looks a little easier than what we've been doing lately with the fractions and the decimals and all that stuff. But something weird does happen at the very end of this. Everything looks like it's going nice and smooth until you get to the end. All right? So this looks fairly basic, doesn't it? A little distributive property, a little distribute here, distribute the negative through this. All right, that's not that big of a deal. So let's do it kind of quick right here. So this is going to be 2x minus 2, and then the plus 4. This right here, distribute the 4th, so that's going to be a 4 plus 4x. Now make sure you distribute that negative through the whole entire thing. Don't just make it negative 2x plus 2. What's it going to be? Negative 2x what? Minus 2, because you're distributing that negative. Again, it's kind of like a negative 1 out in front. Okay? So I would go negative 1 times 2x, which is negative 2x. Negative 1 times positive 2, which is negative 2. So at this point right here, that right there is the one little thing that may have tripped you up a little bit. But now that we see it, hopefully you'll be able to do that. Let's add like terms. On the left-hand side, let's add like terms. You can't add anything with the 2x. I just put 2x down. Negative 2 plus 4 is positive 2. Add like terms over here. 4x minus 2x, that's 2x. And then 4 minus 2 is a plus 2. Now, take a look at it. What's it look like going on here? Look at the left side, look at the right side. Tell me something about it. Do you recognize? It's exactly the same, isn't it? It's exactly the same. So look what happens if I try to get the x on the same side. Let's take this 2x and put it over here on the left-hand side. So if I subtract a 2x over here, I subtract a 2x over here. That's a 0. That cancels. That cancels. Guess what I don't have now? I don't have any x's now. So how in the world am I supposed to solve for x if I have no x's? Same thing here. If I subtract a 2 and I subtract a 2, that cancels. Everything cancels. What's up with that? So how do we get an answer? Well, let's go back to what we had before. Remember I said both sides are equal to each other? So let's think about this. Let's think about what values for x could you put in for the left side that will also equal the right side. You could put a 1. Okay, say it, Alex. What'd you say? You could put anything over here for this x. Because I'm going to put the same exact thing in for this x. If the two sides are equal to each other, does it really matter what you put in for x on the left-hand side and put on the right-hand side? No, as long as they're the same thing because it's x, right? It has to be the same number. So really, what's my answer? All of them. All the numbers in the world, all the real numbers, okay, you could put in for x, all right? So all the real numbers you could put in for x, and that's your answer. So x, and there's a way, I don't know. I have this written down in my notes. I don't have the book in front of me, but I wrote this. I don't know if the book writes this, but I don't know if I just wrote it or what. But x equals every value. Okay? Now, there's other ways that people will write. Some people will write this, like x you remember this is the set of all numbers? I don't know. I don't even know how you'd write it like that. And remember you had the brackets. Remember this thing? And you put that little bar such that X is all the real numbers. Here's probably what they do. They probably say is a subset of all the real numbers. Look at that R. Isn't that crazy looking? I put two things down and then I went like this. Okay, that's the symbol for all the real numbers. Anybody seen that before? Yeah. Okay, so that's kind of what that means. So they're not asking to write it super fancy like this, I don't think. I don't know. Has anybody got a book in front of them? Open up to this page. Does anybody see what they write as an answer? I mean, I could get the book out, but I just don't feel like doing it. Anyway, I'm fine with this. X is every value. That's value. We call this, listen to me, we call this an identity. This is an identity equation, all right? It's an identity, which means I had a teacher present it like this, and for some reason I always remember it. If you look in the mirror, okay, you're looking at exactly what you look like. Would you agree? All right, so I got one thing right here. So I got an X right here. And then here's the mirror right there. What's on the other side? It's X, okay? 3 is equal to what? 3. These are all identities, all right? So this right here is an identity because the left side is exactly the same as the right side. Does that make any sense? So that means any value for X could work for this, any value, okay? All the real numbers, if you want to put that, or if you want to write it down. Let's write it down like this. This might be a good way to write the answer. All the real numbers. Then you don't have to worry about these crazy symbols and stuff like that, okay? So that would be the answer, all the real numbers. Any real number works. Alex, question?
I was going to say, I checked the book. It just ends with the 2x plus 2 equals 2x.
And so they don't give you like a final answer?
No.
That's it? But they do say it's an identity though, don't they? Yeah. All right, but what I circled right there, that'd probably be good. If you see this on a quiz or a test, all right, and the left side is exactly the same as the right side, you just say all the real numbers is our answer, okay? Every number. Even if you wrote that, even if you just wrote every number, all right? Technically, it's all the real numbers because there are numbers that are not real numbers. We'll talk about that some other time. They're called imaginary numbers, but we're not going to deal with that right now. Let's do one more example like this, and we'll hit something else, okay? We got to go a little faster on this one because we got some things that are just slightly different in the next set of examples. So that was an identity. This one has another name, but we will work it out until we get some kind of an answer. Then we'll look at it and decide what we're going to call it. This looks similar to what we did just the other day. Remember the stuff that looks like this? We have fractions.
Yep.
All right, so what are we going to do first? Now, there's no distributing here. Okay, there's no distributing on this one. Well, we're going to do some distributing, but right now there's no distributing. Well, what don't you like about this thing? Now, I don't want to make the 4 into a fraction. That would make it worse. Okay, what don't you like about this problem? Before we didn't like the decimals, right? On this one, what don't we like about it? The fractions, that's right. So let's get rid of the fractions. So what do you think, Alex? What are we going to do with the fractions? We're not going to add them. That's right. I need it to cancel out. I need this 3 to cancel out with something on the top. All right? So what could it cancel out with? Well, a 3, right? A 6 would cancel it out. A 9, any of those, right? Anything that's a multiple of 3. But what about this one? What cancels out with that? A 2. We're fine with the 3 right here, okay? We're fine with the 3 on top. How do I get rid of the 2? What would have to be on top here? Could be a 2, could be a 4, could be a 6, any even number, right? That 2 would cancel out with. But what number does the 3 and the 2 cancel out with? What's the smallest number? 6s, okay? That's called the least common multiple. Remember that, LCM? Yeah, you probably learned that back in the day. All right, so that's what we want to do. It's kind of like finding common denominator. 3 and 2 and 3. What's my common denominator? 6. So what I'm going to do is I'm going to multiply everything by what? 6. Oops. That. Okay. Put it in the wrong spot. Put that, and let's put a 6 right there. Okay? Now, what I'm going to do, I just showed you that to show you that everything's being multiplied by 6. Whatever you do to the left side, you got to do the right side. So what I'm going to do is this. I'm going to write 6 over 1. Many of you won't have to do this step that I'm doing, but I'm doing it just because. I'm going to actually take that 6 and distribute it through here. Remember I said earlier somebody said distribute. Well, there was no distribution before, but now we put the parentheses there and that number on the outside. Now we do have distributing. All right, so now I'm going to go what? What's that going to be? 6 times what? No, not times x. Times what? 4x. Okay? I'm going to do the same thing here. 6 over 1 times 3 over 2. Now again, a lot of you guys might be able to do this part in your head and get to the next step. And if you can, that's fine. But I'm just doing this for everybody. So 6 times, well, yeah, I'm going to put this in parentheses. Since I'm multiplying that subtraction, okay, I got to put that in parentheses over 3. So that's how we can write it. So basically, all I did was multiplied everything by 6. Got it? Nico, you getting all this? Kind of hard to pay attention when you're not looking up here. All right, let's do this. What happens here? Remember we said we want to get rid of the denominators? So that 3 will cancel with this, but what are we left with on top? A 2, right, because 3 divides into 6 2 times, okay? Right here I can just multiply. All I'm doing right now is just canceling out my fractions. Remember, that was my whole goal to begin with, right? Was to get rid of the fractions. That's what I'm trying to do, all right, because I don't like the fractions. So that 2 divides into this 6 3 times. This 3 divides into this 6 2 times. All right, now let's write it nice and neat, make it look a little nicer. This 2 is being multiplied by that whole x minus 1. What am I going to have to do with that whole x minus 1? Put it in what? Parentheses. See, that 2 is times that x minus 1. You got to put it in parentheses. So I did. Again, you might have been able to do this step in your head. You might have been able to distribute in your head and just write what it is. But I'm showing every single step. Plus 24x equals, what happens here? That cancels out to be a 3. 3 times 3 is 9. Plus, and what do we have here? Let's make this look like a plus. What do we do here? Let's just write it with, we could have distributed right in our head, but I'm going to write it all out so you see what's going on. So now, we took all those fractions and we got this. This is old stuff. We did this a couple days ago, several days ago maybe. All right? So this is what we're left with. Now let's go ahead and finish this up. Let's see what happens. So far, it looks like a pretty normal problem. Looks like the problems that we did before. But when we get to the end, something weird's going to happen. So let's watch. So let's distribute the 2. I'm going to go a little quicker now. 2x minus 2 plus 24x equals 9 plus, now this 2 is being distributed. Don't distribute the 9 because you got a plus in between. It's 2 times that parentheses, so that's that, 26x minus 4. Let's add some like terms. 2x plus 24x, what's that? 26x minus 2 equals, I got a 26x over here, and then this adds up to be what? 5. Is this an identity? Is it exactly the same on the left and the right? No, it's not. But what does happen that happened in the other problem? If I get the x's on the same side, how would I do that? Subtract a 26x, subtract a 26x. But look what I'm left with. That cancels, that cancels, that cancels, that cancels. So my x's go away, just like they did with that identity thing. But what I'm left with is a little different. Okay, before, everything canceled out, right? I was basically left with 0 equals 0. But on this one, I'm not. What am I left with? Negative 2 equals what? 5. Now, does negative 2 equal 5? Of course not, all right? So this is not a true statement, is it? All right? So there is no values. On the other problem with the identity, every single real number would work if you put it in for x. What about this problem? There are no numbers. If you put it into the original problem, there are no numbers. There's not one number that exists that's going to make that left side equal the right side. All right? So this is not equal to, all right? There's nothing. There's nothing you could put into it. A fraction, a decimal, a whole number, a negative number, anything. You're not going to be able to get this left side to equal the right side. So what we say, the book calls this a contradiction. All right? It's a contradiction. It's not an identity. It's a contradiction. Do you see the contradiction? Negative 2 does not equal 5. That's your contradiction, right? They contradict each other. They're not equal to each other. Oh, gosh. Let's try this again. Boom. Okay, they do not equal each other. So what's your answer? Well, it's not really the word contradiction. That's not your answer. You just say no value, or we say no solution. Okay, so we say no solution. So that would be our answer. No solution. So this is what I would circle as the answer. Okay? You see the difference between this and the first one? Okay, the first one is every single number works because the left side is exactly equal to the right side. Man, you guys are dropping like flies. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Got your heads down on the desks. And we're taking a quiz on Wednesday. How about that? And you're going to see this stuff on the quiz. So don't go crying to me. I'm just pointing it out. Not getting mad. Well, I am a little bit inside. But look, I want you to... Somebody told me the other day, you should be like Mr. Cheadle because he doesn't care if people don't pay attention. He just says, well, that's on you. You need to deal with it. And I agree. I completely understand where he's coming from. But there's something inside of me. There's just something inside of me that just cannot allow you to just sit and do nothing because I want you to learn this stuff. And I'm sure Mr. Cheadle does too, but he's putting a lot of responsibility on you, which I probably should. So I'll shut up and just do this problem. All right, we're solving for h. That's a weird letter to solve for, but here's what the equation is. It's a equals 1/2 base times the height. This is actually the formula for what? Anybody know off the top of their head? It's the formula for something. It's a geometric shape. It's very basic. It's a triangle. That's correct. Okay, that's the area of a triangle. So what they are asking you to do is solve for h. You're like, what? Solve for h? I got 3 variables here. How am I going to do this? Well, you're going to get h by itself, but in your answer, you're going to have some other letters in your answer. You're not just going to come out with like x is 20, or sorry, h. H is 20, or h is 78, or something like that. You're going to have other letters in your answer, okay? We say this. Here's a fancy way that math teachers say it. They say we're going to solve for h in terms of a and b. When they say in terms of, that means the a and the b is going to be part of your answer, okay? So let's do it. Let's solve for h. And I'll tell you what. Let's make this a different color. I like that pink color. All right? So let's solve for h. Let's get that by itself. So what is with the h that we want to get rid of? The b and the half. That's right. Let's get rid of the half first. You okay with that? So how would I get rid of that half if it's being multiplied? People would say, well, you divide, right? If you get rid of something, you divide, right? But what's the same thing as dividing by a half? Multiplying by 2. That's a lot easier. I wouldn't divide by a half. I would multiply by 2. See what happens? The 2's cancel out. The 1's cancel out. You get rid of it. But if you do that to one side, you got to what? Do it to the other side. Everybody see that? That cancels out. Now, what's the next thing we need to get rid of? The b. How do we get rid of that b? It's being multiplied by the h. How do we get rid of it? Multiplied by 1? How to get rid of the b? Divide by b. That's right. Divide by b. And that is basically your answer. Let's write it nice and neat. H equals what? 2a over b. And that's your answer right there. It's a weird answer because it's not just a regular number. Okay, you got letters as part of your answer. But you've seen stuff like that before, right? You've had numbers as part of an answer before. So that's what it is. We got 2 more to do, and then we'll be done. Example 11. It says solve for t. Now these are all, solve for t. All right, these are all actual formulas, okay, that you could use in real life. All right, all these things right here. It looks like fort, but it's supposed to be separate. Solve for t. All right, so here's the formula. A equals P plus PRT. This has to do with money and principal and time and rate and all this kind of stuff, okay? So, but we don't care about that. All we want to do is get t by itself. So let's do what I did earlier. Let's just make that a different color so it stands out a little bit more. There we go. Back to white. All right, so we want to get t by itself. Now, we have no numbers in here. You're like, Mr. Hammer, what's up? How am I supposed to solve for something if I got no numbers? Well, what do these letters represent? They represent numbers, right? So we can do the same thing we can do with these letters as we can do with regular numbers. So what's the first thing I want to get rid of here? This p right here that's being added, okay? So always get rid of what's being added or subtracted. So if this was like a 3, it would be pretty obvious, right? Okay, I got to get rid of that 3. But it's a p, so we get rid of that. So we subtract a p from both sides. Now here's how I'm going to write it. I'm not going to write it up and down like that. I'm going to write a minus p. And what's that equal? PRT. So that's our first step. Just subtract p from both sides, no big deal. Now, one more step and we're done. That's it. So I got to get t by itself. What are these things doing to it? It's multiplying. How do you get rid of something that's being multiplied? Divide. So divide by p what? PR. And then I take that whole thing and multiply that by what? PR. Now, does this p and this p right here cancel out? They don't, because this p is part of a subtraction problem up here, okay? If it was a times p over PR, then they would cancel out. But right now they don't, because it's a minus p. And that's your answer. So t equals a minus p over PR. And that's how you write your answer. It's not so bad, is it? You don't really have to do any arithmetic, do you? You just have to know whether you add or subtract, multiply or divide, and you do it to both sides. No big deal. We got one more. Just enough time. This one, we're going to solve for C. This is example 12. Now, it used to be back in the day, if you wanted to go from Fahrenheit to Celsius or Celsius to Fahrenheit, you'd have to actually write it out and figure it out. Or maybe there was a chart or something. But nowadays, you can Google it. I've done it dozens and dozens of times. Okay, I want to find out what the temperature is in Celsius. I don't know what it is. I don't go to this formula. I used to, but now I just put it in Google and it'll tell me what it is. So on this, we are changing it from Fahrenheit to Celsius. So we're going to solve for C. C is the temperature in Celsius. Okay, so here is a formula. Here's the formula for Fahrenheit. All right, it's 9/5 C plus 32. It's a very common formula. What I'm trying to do is I want to find out, so like if you knew what the temperature was in Celsius, like when I lived in Australia, actually back then they were just going to the metric system. So I don't know if we used Celsius or not in 1973. That's when I was in Australia. 73 and 74, I was in Australia. It's a long time ago. So anyway, if you know what it is in Celsius, you can multiply it by 9/5 and add a 32. What if you wanted to know generally what it is in Fahrenheit? What's 9/5 really close to? This is 1 and what? 4/5, right? So this is really close to 2. So if you have something in Celsius, how could you figure out generally, fairly close, not exactly, just multiply it by 2 and then add 32 to it. Okay? So that's one way that you could find, again, very generally, what it is in Fahrenheit. But what we want to do is solve for C. So let's get this by itself. We only got a minute left. So what's the first thing I'm going to get rid of? The 32. So I'm going to have what over here? F minus 32. I'm not going to show it, but you know it cancels. We kind of did this already. How am I going to get rid of this 9/5? I could divide by 9/5, but what's better than dividing by 9/5? Multiply by 5/9. Okay, that way, the 5's cancel, the 9's cancel. If I do that to the left side, I also have to do that to the what? Well, I did it to the right side. Now I got to do it to the left side. Yeah. So it's times 5/9. 5/9 is kind of close to what? It's kind of, not 2. It's kind of close to 5/10. What's 5/10? It's not 2. 5/10. It's 1/2, right? So if I know the temperature in Fahrenheit, I take 32 away from it, and then I take half of that, and then I'm pretty close. Not exactly, but I'm pretty close to what it should be in Celsius. So that's one way that you could do it. So that's what that is. All right. Now, I think I've assigned 3 different 1/5s. I got a 1/5A, B, and C. All right. I think I wrote that on your lesson plan thing. Didn't I? Yep. So tomorrow it says, what's it say tomorrow? Go over and collect what? Sections 1/5A, B, and C. So you need to find them, okay? You should. I've already assigned A and B. I don't know if I've assigned C or not, but today I will. So it's from section 1/5, and it's 81 to 109. And it's just the odds, so that's nice. It's really not that many problems. So that's 1/5C. So that's your homework right there. It's page 57. It's page 57. So tomorrow I'm collecting 3 homeworks from you, okay? 3 homeworks I'm collecting from you tomorrow, all right? 3 homeworks. So have those ready. We're going to review for the section 1/5 quiz, and then we'll take the quiz on Wednesday.